Welcome back to Dog Color Genetics, figuring out the mystery of your pet since November 2016. In today's lesson, we're going to learn about 3 loci: the B Locus, the D Locus, and the G Locus. Before I start the episode though, I'm going to suggest that you watch the previous 2 videos to get caught up with today's lesson. Firstly, we'll start off with the B Locus. The B Locus is also called the liver series. But what exactly is liver? Liver is a rich brown color that is a modifier of black eumelanin only. It is a recessive gene, therefore big B is non-liver and little b is liver, and in order for a dog to be liver, it must have the genotype little b. This means that a liver puppy can be born from black parents if both of the parents are carriers of the liver gene. When a dog is liver, all the black on the coat will turn into liver, which includes saddles, sables, merle, etc. It is genetically impossible for a liver dog to have even one black hair in its body. But a liver dog can have red hairs depending on the K and A loci. Liver turns the nose brown and the eyes amber, and sometimes the nose can look pink. The nose is usually the most reliable way to tell a liver from a black or blue. Sometimes dogs are born with only red in their coats, for example from sable or recessive red, but appear to be brown. Even a red dog, like the golden retriever, can be genetically liver if its nose is brown or pinkish. Sometimes liver is given different names. For Labradors, it's known as chocolate, and in some breeds, it's known as red or brown. Liver merles are usually called red merles. Secondly, we will learn about the D locus. This locus is home to the dilution gene. It is a recessive gene, so little d is dilute and big D is non-dilute, and in order for a dog to be a dilute, it must have the genotype little d. The dilution gene affects black and liver. When a dog is homozygous for dilute, a black dog will become blue and a liver dog will become Isabella. A blue or Isabella can have any coat pattern, but whatever they have, any black or liver on their fur will be turned into blue or Isabella. It is genetically impossible for a blue dog to have any black on its coat, and for an Isabella dog to have liver. The main giveaway that a dog is a dilute is, again, through its nose color. The coat may be entirely sable or recessive red, but if the dog has a blue nose, it's genetically a blue dog. But Isabella is trickier. An Isabella dog's nose is actually very similar to a liver dog's nose, since a liver can have pink noses. The dilution gene also causes the eyes to lighten to amber. The dilution gene is actually usually present in specific breeds, which I will name. The American Stafford Terrier, the Beagle, the Bearded Collie, the Border Collie, the Borzoi, the Canary Dog, the Cane Corso, the Chesapeake Bay Retriever, the Chihuahua, the Chow Chow, the Doberman, the Finnish Lapphund, the Foxhound, the German Pinscher, the Great Dane, the Greyhound, the Harrier, the Italian Greyhound, the Kelpie, the Miniature Pinscher, the Moody, the Neapolitan Mastiff, the Newfoundland, the Otterhound, the Peruvian Inca Orchid, the Plot Hound, the Potengo Portugueso, the Pomeranian, the Rat Terrier, the Russian Toy Terrier, the Schipperke, the Sharpei, the Shih Tzu, the Slovakian Pointer, the Stafford Bull Terrier, the Thai Ridgeback, the Tibet Mastiff, the Weimaraner, the Whippet, and the Zolo Eats Queently. I hope I said that right. Within most of these breeds, the blue gene is very rare, except for the Weimaraner and the Slovakian Pointer. They are the only breeds that come entirely in dilute and no other color. Dilution seems to occur from time to time in most breeds of dogs, besides the breeds I mentioned. It is definitely a very rare trait. There is a few genes in dogs that cause dogs to display a grayish color when they are not dilutes. Merles give a bluish base coat, and the graying gene also turns the dog gray. But of course, the way to tell a black from blue is the nose. If the dog looks blue but has a black nose, it is in fact black with a graying gene. And speaking of the graying gene, that is what we will talk about next in the G locus. The graying gene is a dominant gene that only affects eumelanin, meaning big G is graying and little g is non-graying. A dog only needs one copy of big G to express graying. Graying is only expressed in long, curly, and wired hair coats only, so a short-haired dog may have the gene, but it will not show. Graying does not affect the nose or eye color like we discussed before. It is also a progressive gene, so a dog with graying is born solid black or liver and becomes lighter as it gets older. A dog with dilution may also have graying, but it's rare for the two genes to occur in the same breed. Graying does not affect pheomelanin in the same way. Some breeds with graying also come in shades of cream, but it is not necessarily a strong connection, as the Yorkshire Terrier can prove with its rich tan. Graying can affect dogs with tan markings, but it does not always affect masks like the Kerry Blue. Their main coat may turn to silver while leaving their hair on the muzzle black. It is unknown why this happens. Dogs with graying may take years to turn from black to gray. Graying only occurs in a small number of breeds, and the most notable are the Old English Sheepdog, the Bearded Collie, the Tibetan Terrier, Polish Lowland Sheepdog, the Beddington Terrier, the Dandy Dinmont Terrier, Basset Griffon Van Dien, the Poodle, the Irish Wolfhound, the Deerhound, the Chesky Terrier, the Kerry Blue Terrier, the Havanese, and the Glan of Imail Terrier. Well, this lesson was shorter than the last one, that's for sure. But don't you worry, next time we're taking a look into the E Locus, and even two that I did not mention in the introduction video, the I Locus and the C Locus. Can't wait to see you then!